Today we're going to continue on with energy. This is 5.2 kinetic energy, so make sure you have your physics notebook out or you're following along with the notes online and that you have it labeled with today's date and 5.2 kinetic energy. So last class we talked about potential energy, and the other major type of energy is kinetic energy. And kinetic energy is the energy of an object in motion. And if you think about what kinetic means, or say like a kinetic stretch if you're an athlete, means that it is a stretch that you do while moving. So thus, kinetic energy has to do with energy in motion. Objects with kinetic energy are actively capable of doing work. So for example, an apple moving at 10 meters per second can do more work or more damage than it was moving at 1 meter per second. You would much rather, say you're playing baseball, you would much rather be hit by a baseball that's moving 1 meter per second versus 10 meters per second if it were to hit you. Or an apple moving at 10 meters per second can do more work than a cherry moving at 10 meters per second because, of course, that apple is bigger. So would you rather be hit by a cherry or an apple if they're going at the same speed? Probably a cherry because it'll do less damage. Kinetic energy, therefore, depends both on speed and mass. Our equation for kinetic energy is Ke equals half mv squared. Ke equals kinetic energy measured in joules. M we know is mass measured in kilograms, and V is velocity measured in meters per second. Thinking about proportions or relationships, K and M are directly proportional because they're on opposite sides. So we have K and M directly proportional. K and V squared are also directly proportional because they're on opposite sides. Notice that it says V squared, so we cannot forget that squared. It's not K and V are directly proportional, it's K and V squared are directly proportional. And then M and V squared are inversely proportional because they're on the same side. Same side means that the opposite thing will happen to them. Again, this is different than our normal proportions because we do have our squares. It is a bit tricky. Since K is proportional to V squared, if V doubles, K will actually quadruple, and we'll talk a little bit more about that, especially in examples in class, but V squared doubles means we have to do 2 to the squared. 2 squared is 4, so K thus quadruples. Continuing on. One other example is if M gets multiplied by 9, V will be divided by 3 because 3 squared is 9, so thus if we're dividing, we have to do 9 the square root of 9. K depends more on speed than mass, and that is why it has V squared, or if you think about a car crash are much more dangerous at speeds above the speed limit. The faster they go, the more dangerous they are. Because a car has more kinetic energy at higher speeds, it can cause more damage in a collision. So our first example problem that we're going to use our equation for is what is the kinetic energy of a 100 kilogram tiger running at 15 meters per second? Of course, we read our straight across equation. We start putting our numbers in. So half times 100 kilograms times 15 meters per second squared. I like doing everything in parentheses. And so my final answer there would be 11,250 joules. Don't forget your units. Our next example is we have to solve. It says a 35 kilogram child has 190 joules of kinetic energy after sledding down a hill. What is the child's speed at the bottom of the hill? So we have to get V by itself. This is a bit tricky. In order to get V by itself, we can start by multiplying both sides by 2 to get rid of our half. And then we divide each side by M to get rid of our mass to get V squared by itself. Now this is not done. V is not by itself. If you only give your teacher this on a exam or on a quiz, you will not get full credit. Because really we have to take the square root of it. So if we take the square root of one side, that is the opposite of squaring something. So if we take the square root of both sides, we will then get v equals root 2k over n. That is how we isolate our variable. Next, we can do everything that is under the variable sign. So it's kind of like there's parentheses here. So I plugged my numbers in. 2 times our kinetic energy of 190 joules. Multiply that out and then divide by our 35 kilograms will give us our velocity. So in our square root symbol, we have 10.857. If we take the square root of that, our final answer is 3.295 meters per second is our velocity. Make sure you have this one written down in your notes because this one is a bit challenging. And then our final example problem is we have another sledder. They have the same mass, but with triple the speed. So we have our straight-across equation k equals half mv squared. We're tripling the speed, thus it's times 3, but we can't forget that we have squared by the velocity. So thus we have to do times 3 squared. Our mass stays the same, so I can ignore mass. But then I have to multiply k times 3 squared, which is also the same as 9. So I'm doing 190 joules times 9, or times 3 squared, to get 1,710 joules. Make sure you complete your IP that is on Google Classroom. Email your teacher or come to class with questions if you have any, but we will be doing some more review in class during your next physics class.